Good morning, students. We are looking at first the example to understand what is the difference between f of minus x and f of absolute value of x minus f of x and so on. So let me take an example and see what happens if I do f of minus x. So you need to understand that when I present x to the function, what the function receives is negative value of that. Now in the graph that I see, I don't know the equation of the function, but I see a graph. So I'm seeing that at plus 1, I say for example have a value of 1. At 2, I have a value of say 2. At 3, I have a value of 0. At minus 1, say I have a value of minus 1. And at minus 2, I have a value of 0. So this is the graph that I'm seeing. If I have to look at f of minus x. So when I give the function minus 3, when input is minus 3, the function will think of it as 3. So what will the answer be? It will be 0 because the function is the same. That function could be multiplication operation, the function could be addition operation, the function could be log, exponent. I don't know what the function is doing, but whenever it receives 3, the answer is 0. So when I give minus 3, f of minus x will think it has got 3 and then it will give the answer 0. So essentially what I'm trying to tell you is that on the negative side of the x-axis, it will behave the same way that it is doing on the positive value. I've not drawn to scale, so it may not look, and on the positive side, it will behave like the negative one. This is the graph of f of minus x given the graph of f of x. So I don't know the equation, but all I'm saying is that the function gets reflected along the y-axis. Reflection along the y-axis. Okay, now let me see what is the meaning of minus f of x. That means after the function is done, I put a negative sign. After the function is done means f of x is the y coordinate. So what is getting affected is the y value. All the positive values of y will now become negative. And all the negative values of y will become positive. Again, I'm not drawn to scale, so this is minus f of x, which is saying it is reflection along the x-axis. Whatever was above the x-axis got below, and whatever was below the x-axis went above because it got reflected. Everything now has a negative sign in front of it. Let me show you the original graph again, and now look at what happens when you are taking the absolute value. So this is the function. Okay, the function has some negative portion and some positive portion of the graph. And let me see what is the meaning of absolute value of f of x. What is the absolute function? Absolute function removes the sign, like it is also called modulus function. It removes the sign. So if I have modulus of minus 2, I will see it as 2. The negative sign is removed. So if I am looking at this function, there is a positive portion of the function which will stay as it is because absolute function doesn't do anything to the positive portion. But the negative part of the function, which is between 0 and minus 2, because it is absolute, what will it do is instead of showing it below the x-axis, it is now going to show it above the x-axis. Do you see the difference between minus f of x and absolute value of f of x? In minus f of x, what was above the x-axis came below and what was below the x-axis came above. So there was a reflection. But when I do modulus of f of x, only the negative part of the function comes above the x-axis. Nothing changes on the positive side. Similarly, let's see what is the case when I do f of modulus x. Again, this is my function. I'm not drawing to scale. And we looked at what is f of minus x. And we said when I do f of minus x, the left portion comes on the right. Sorry, that's the left portion will come on the right and the right portion will go on the left. That's how the graph will look like. However, when I do, my question was f of mod x. What happens when I do f of mod x? When you do modulus of x, the function will never see a negative value of x. It will not know that you have given negative values because the modulus sign will remove the negative sign. So the function will think it has always got positive values only. So on the positive side it is this. Even when I give it a 0, -1, -2, it thinks it is receiving the positive values only. So it will behave the same way on the negative side as well. I'm not completing because maybe you are only giving values till -2. But if you had given -3, then yes, it would have completed. So whatever was on the right side, that gets reflected on the left one. The left side vanishes because the function doesn't even know that you have given negative values of x. So this is reflection along the y-axis, but with the modulus sign, it's not reflection, but only the right side is repeated on the left. Say there was no right side, I only had function the negative values. Then what will happen? Well, then it will not be seen. Let me give you an example. If I had ln of x, you know how ln of x looks like? Something like this. Ln of 1 is 0. If I had done ln of mod x, now even if I give negative values of x, it will behave the same way as positive values because of the modulus. So I will get the function to be present on both sides. What if I had done ln of minus x? Well, then only the right side portion would shift to the left side. This is ln of minus x. That I didn't have anything on the left, so there is no question of reflecting the left on the right. Only the right portion gets reflected on the left. Right? So that's the difference between the modulus and the reflection. We will go further and look at one example to summarize all the transformations that we have learned till now. So let us look at that example. So that example is, it's again, what I'm doing is I'm not trying to give you values or equation. I'm rather showing you the function on a graph. And like I said, it is not drawn to scale. So you will have to be careful about that. I'm not showing you all the values. There's 3 and 4 here. And this is how the graph looks. I don't know what is the underlying equation. In fact, this doesn't have a single equation. There's one straight line between -3 and 0. There's another straight line between 0 and 2. And there a third straight line between 2 and 5. Correct? So there is no single equation defining this. But that's fine. What I want to do is, I want to look at different transformations for this function. And let me show you those. So the first one is f of x minus 3. What transformation is this? This is a function whose graph I know. And -3 means vertical translation 3 units down. So every single value on the function, every single y coordinate on the function is moved 3 units down on the graph. So my new points will be minus 3, 0 will become now minus 3, minus 3. I had 0, 3 will become 0, 0. I had 2, 1 will become 2, minus 2. Okay, so let me mark this minus 3 a little further down. So this is minus 3 and I will have a minus 2 here. And then 5, 2 will become 5, minus 1. So now let me connect the graph. The shape looks the same, but it is shifted 3 units down. So this is f of x minus 3. So shift down. That's vertical translation. The function remains as it is. Nothing happens to the shape. There was value something below, beyond minus 3 also in the graph. So I will show it as it is. I don't know the values. The values that I know, I will mark them correctly. The next is f of x minus 3. What am I doing? I'm first changing the input and then feeding it to the function. And this is, if you remember from last time, this is horizontal translation. But translation which side? There's a minus 3, so I'm going to shift to the right. How do I understand this minus 3 is shifting to the right? See, the function original, look at the original function. Look at my original function. When the function gets 0, the answer is 3. Okay. So what should I give to the function when it is f of x minus 3? If I get 0, I will get back 3. So if I put x as 3, 3 minus 3 is 0, and therefore the function will think, oh, I got 0, so I should output 3. So earlier, if I gave 0, it gave me 3. Now I have to give 3 to give back 3, because I have made the input as x minus 3 rather than x. Similarly, earlier when I gave 2, it gave me 1 back. Now how much should I give? If I have to think, if the function has to think it has got 2, I will have to make this x 5. Then only the function will think it has got 2, because 5 minus 3 is 2, so and f of 2 is 1. So I have to move every input 3 units to the right. Then I will get back what my original graph is. So move the function 3 units to the right. So instead of minus 3, 0, I will have 0, 0. Instead of 0, 3, let me mark it a slightly higher place. I will have 3, 3. Instead of having 2, 1, I will have 5, 1. Let me mark it a little below so that I have place for a 2. And instead of having 5, 2, I will have 8, 2. Again, the shape looks the same. I'm just moving. The y values are not changing. The y values are the same. This is 3. This is 1. And this is 2. These are remaining the same. It has moved to the right. So horizontal shift right. How did I know I have to shift right? Because there was a minus 3. It was a plus 3. I had to shift left. Okay. Next transformation is 2 times f of x. That means the function value is multiplied by 2. That means the y coordinate is multiplied by 2. Okay. Minus 3 comma 0 will remain minus 3 comma 0 because 0 times all the y coordinates, 0 times 2 is 0. 0 comma 3, the y coordinate will now become 0 comma 6. 2 comma 1 will become 2 comma 2. And 5 comma 2 will become 5 comma 4. So this will become 4. This will become 2. So what has happened to the function is vertical stretch. Every y value has become twice. Y coordinate has to be multiplied by 2. Okay. Then what is f of 2x? If this was 2 times fx, so f of 2x means the x coordinates are changing now. How are they changing? Now look at your original graph. The original graph had f of minus 3 as 0. Look at your original graph and you will know what I'm saying. F of minus 3 was 0, f of 0 was 3, f of 2 is 1, and f of 5 is 2. So I'm just looking at that and writing it again. F of 0 is 3, f of 2 is 1, and f of 5 is 2. This is all the information I had. It is the same function, nothing has changed. But instead of giving x now, I am giving 2x. What value should x have if I have to see minus 3? Instead of giving x, if I am giving 2x, what value should x have if I have to see minus 3? Well, x should be minus 1.5 so that into 2 the function will think it has got minus 3. What value should x have if I have to see 0? Well, x has to be 0 only. What value of x should I have such that 2x is presented as 2? 2x equal to 2 means x has to be 1. X has to be 1. Then 2x will become 2. If function has to get 5 as the input, x has to be 2.5 because 2x will again become 5. Essentially all I'm saying is at half the value of x, at half the x coordinate, I'm able to get the same graph. So instead of having, let me draw the graph and then I will show you what I mean. Instead of having minus 3 comma 0, I have minus 1.5 comma 0. 0 comma 3 remains 0 comma 3. Instead of 2 comma 1, I have 1 comma 1. And instead of 5 comma 2, I have 2.5 comma 2. So do you see the function is the same, but it has got compressed on the horizontal axis, compressed. Okay. Now, I want you to try something on your own, and that is 2 of f of x plus 4. Look at your original graph. Try this on your own, and then we will discuss further.